folks, what's happening? It's Steve Jennings from Grasshorse here. Welcome to the first episode of Robot Chores. I see that, I don't know if we're connecting up to all of the streaming outlets or not, but I guess we're on most of them. So anyway, we're going to go ahead and get started, and maybe the other ones will kick in, maybe they won't. Anyway, we're going to be working today on, not that. Let's see if we can get these buttons right here. Okay, so we are going to be basically making the code for a 2-channel stepper sweep, or a servo sweep, in the Arduino platform. And let me kind of turn the microphone here a little bit. And so what we see over here right now is this is another Arduino that's plugged in there right now. And then we have this Arduino here with Arduino Proto Shield on top of it. I believe it's made by Seed Studio. And it's a very simple circuit. Basically, there is ground and power. Okay, let me go back the other direction. We have power coming in to power the servos. We have 6 volts of power in this battery pack, and it comes into down here onto these little rails down there that we then run the power into. And then we run that power into a voltage regulator down here, and so we get clean 5-volt power out of it. Okay, so as the servos start to get more stressed and everything, the power won't fluctuate and damage electronics. And so then we have that power run from the rails over here to these pins that go into the Arduino over here to the ground and the 5-volt. And so the Arduino can be just unplugged from the USB. So it's not even using the USB power right now. It's actually using the power. Hopefully, it's using the power from the batteries here. Now, I left the batteries on for a while. I don't think anything was plugged into it. They should be okay. If not, we'll swap out the batteries. But I believe we have a good amount of power on these things. And then, and on those rails, we then run the ground and the power to both of these 2 servos right here. And then we have these 2 digital outputs that are then run to each one to the rails up here that are separated out. So it's a little bit hard to see it, but the bottom 3 rails here on this, I jumpered them over so that there's basically eight holes that you can solder into, and then there's 4 holes on both sides there for the digital pins, which are digital pin, I believe it's 2 and 3. All right. So anyway, we have a long-term project, or not long-term, we have a bigger project than this one episode, and that's that we have these characters that we've created for a project. It's actually a puppet show that we've created, and we want to have the ability to have servos drive these characters in the long shots. And so you can see that like here's a character right here. This is Serenity, and we basically like to attach to the back some sort of something to hold on to there, and then be able to drive this back and forth in the shots, in the long shots, because there's going to be about 12 of these. I believe there's 12 spots total, and they're basically 6 benches, and there are 2 people per bench, or 2 characters per bench, and we want to drive and have an Arduino at each one of those benches to then drive 2 servo motors. So that makes up 12, right? 6 benches, both 2, 12. So the first part of what we have to do is actually just creating a sweep. And so And how I make these, streams, I don't necessarily pre-plan it. I have maybe an idea what we're going to work on, but essentially, I want you to see the whole process, and it allows me to make videos more often, and hopefully it allows you the opportunity to see how you troubleshoot through problems instead of necessarily just seeing something that's kind of already troubleshot and rehearsed and the like. So anyway, let's go to the code, and let's see here. We have an Arduino Uno that is hooked up to that. Okay, let me back up. Most likely, if you are familiar with Arduino technology, this will probably be a pretty, if you have any experience with it at all, this will probably be very redundant information for you. And, I think this is definitely a beginner level instruction here, okay? So essentially Arduino is a little tiny computer that you can program, and I believe it's an open source embedded electronics technology, and you can program it with I believe its own version of Python, and I'm wrong about that. It's C++, I believe. C#, C++. I'm not totally positive. I know a lot of different languages, and I kind of fake it for the most part. So I'm not trying to present myself as a programmer. I've programmed a lot, but I'm primarily an artist. So I'm approaching it from this kind of perspective, and I'll try to explain it the best I can. But ultimately, why I'm making these videos is to get done what I need to get done for the project, and hopefully they're helpful to you. So, all right, here we go. So when you get Arduino and you hook it up to your computer through a USB cable, you then have this application development environment here on your system. So you go to Arduino. I think it's arduino.cc, I believe, or something like that. And you can download this from their website and install it. And then you can install, it might need to install a driver as well to drive the technology. But essentially, once you plug it in, you need to specify what board you have and the serial port. And we have COM8 is what's there right now. And it comes with examples. And so we're going to be working right from an example today. And we're going to do a servo sweep. All right. So now we have this here. This one is to say that it attaches a servo to pin 9 on the servo object. That's the only thing we're going to change from all of this code here is that I showed you that we connected to pin 2 and 3. And so I'll go ahead and I'll just put pin 2 in there. But this is an example. It's basically, this is setting up an include to bring in the servo library. This makes a new object called myServo. This sets up an integer for the position of the servo to begin with, and then and so this does the actual setup of attaching the pin to this servo object. Okay. And then this is the code that's run in a loop. This is how Arduino is a little bit different programming-wise than other languages in that it is run on a constant loop, and often that is not a great way to program other technologies. Like if you're doing websites and things like that, you often don't want infinite loops running on your technology. So anyway, so we have a loop that's going to run over and over and over again, and it's basically a very simple for statement here. And so for each time that position is equal to 0, right? Take position, and position is less than 180, right? So for if, I'm going to say if, I don't mean like an if statement, but it's kind of, two aspects to an if statement. If position is 0, or it's greater than 0, and it's less than 180, increment it by 1 unit and then run this, okay? And then it's going to do the opposite. Once it reaches 180, it will, and position is greater than 1, subtract 1 from position, okay? So these will run in loops. Both of these will run in loops. This one will take it up to 180, and once this hits 180, it will take it back down to 1. And whereas the loop will be completed, this iteration of the loop will be completed, and it'll go up and it'll run it again. Okay? So what's happening inside these two for statements is that this myServo object is writing the position. And basically the servos accept a position of 0 to 180. Okay? And then it waits while it tries to move that 1 degree. If you want to change the timing of this, you would go through and you would change this delay between each of those writes. Okay? And so the same thing here, exact same thing as this is, but it's going in the opposite direction. Okay? So, with any luck, this will, let me see, we're going to click this to verify the code. I'm going to upload it. And hopefully one of the, okay, it's uploading still. It's done. I hear it already. So you can see that it is just sweeping one of those servers back and forth. Okay? Cool. So now we're going to go back to over here, and I'm going to go in there and set it up so that we can actually have 2 servos run. I might want to just upload a blink or something to that right now to get it to stop moving. I don't know if you can hear it move or not, but examples, basics. Blink is like probably the most simple. Sketch, it basically flashes a light, a LED on the system. Cool, it stopped moving. Great, that's all I wanted to do. So we're back over to sweep here. Let's go ahead and do a save as. And we can go and call this 2 servo sweep. Let's camel case it. All right, so first thing I'm going to do is we will copy this piece here. So we're going to set 2 servos. I'm going to change it from myServo just to servo 1 and servo 2. And then I'll do POS1. I'm just thinking this through here a little bit. POS2 equals 0. This will allow 2 separate positions for the servos. At first, we'll probably have them be the exact same. So we know this is now servo 1, which is attaches to that, then servo 2 dot Cool. All right. I'm going to do all these for Servo 1 first. When I was messing around with this, I know that I was having challenges with having them both try and write at the same time. It just seemed to confuse the Arduino. So let me try this. Servo 2.write POS2. And then we'll add a delay here. My thought is maybe we should make this a variable up here, like this. Like we could write. But let me get the thing going first, and then I'll try and tighten it up a little bit first. All right. Servo 2.write. Okay, and then we will need to take pos1 equal to pos1 plus 1. Sorry, that's position 2. Position 2 is equal to position 2 minus 1. Cool. All right, does that check out? It's done compiling. Upload. I hear it. Did I bomb? Oh, that's great. All right. So cool. They're both running, and they look like they're running smooth. And they're sweeping exactly the same, at the exactly same rate. Let's just try and add like a servo speed. So int servo speed is equal to, I'm going to say, like, let's do 8. Pardon me. Wow, that's awful. Copy that, and let's see if this will work or not. Cool, done compiling. So if there's any luck, this will run. So cool, yeah, all right. So if you want to change the actual speed of how much it's moving, we can change this amount here. Now I imagine that you can also do servo speed 1 and servo speed 2. I don't know how well that will work because one will impact the other. Let me show you the code real quick. So here's what I did. I copied servo speed 1 to servo speed 2. And then down here I put servo speed 1, servo speed 2, servo speed 1, servo speed 2. I have 2 different values there. So we're saving it. We're going to compile it real quick here. Make sure it's hunky-dory. Yep. All right, let's go and look at this. Okay, so that didn't work. And basically it didn't work because it's adding this and this together before it goes to the next position. And so the sweep is basically these two things combined. So what do you say? Let's try and separate this out into, basically do this exact thing here. Copy this, and we're going to make a separate one for, paste, for servo 2. And since we're copying and pasting most of this stuff, it's probably a good idea to actually make this a function instead of doing all this copy and pasting. But I just want to at first prove the idea out before we go into that. So this one here, that's cool here. We're going to get rid of this for this one. We'll get rid of this. Oops. Get rid of this. Okay, we're going to get rid of that because it'll be up here in the code. Let's get rid of this. Get rid of this. And this. Alrighty. So position 1. That's cool, that's cool. This one all should be fine. This one should be fine. This one is not fine. This will be position 2. Okay, it's position 2, cool. Position 1. Position 2. Position 2. Position 2. All right. So now we will compile it, see if it runs, see if it compiles. All right, that compiled. Let's upload it to the server. Servo. The Arduino. And see how it goes. If it does anything different. Hopefully one goes faster, the other goes slower. All right, so now it is, one makes its entire movement before going slowly or quickly. So the servos do have different speeds, but they're not going at the same time. Okay. All right, so what are we going to do? All right. So we are going to need a for loop. Not exactly sure here. I know that we will need to go back to what we did kind of before, but then we need to find a different method to make sure that they are passing information back and forth. And I think that there is like some sort of there's some sort of command that it doesn't have to go through the loop. It's its own embedded process kind of deal. But anyway, let's try some things here. What I wanted to do here was one, you had your position here, but I'd also like to change, be able to change this and this on the fly, so maybe it doesn't have to go those full amounts. So, this is the current position. And maybe I might even change some of the, I might make these a little bit easier to read. Current, so servo 1, current position. Okay. Copy this and paste that. Paste that. I know it's a lot longer of a name, but it just makes it easier for me to read it. I'm going to open up a blink. I'm going to save this real quick. Let's open up the blink again so I don't hear those servos going. It's nerve-wracking. All right, go back to here. And then now this one can be changed. Paste. This is changed to 2. Okay, there's that. I missed one there. Ooh, this was wrong. Copy this one. Save this. Let's double check. Okay, I missed one. Great. All right, so now I want to do an int servo 1 minimum position is equal to 0, and then int servo 1 max position is equal to 180. Copy this. Paste that down here. All right. So we don't have to have them like this. And I would say that in fact, I'm going to take this. Servo min position. So copy this, paste that there. First off, does that check? No, it does not. Servo min position was not declared in this scope. All right, so this should be no different. If this runs, this should almost be no different. It just has some better names in there, and whoop. Well, we might as well see if this works, but I'll be shocked if it didn't work. It's just basically some naming changes to make it a little bit clearer as we're getting more complex. Yeah, it's fine. All right. Here we go. So what we want to now do is for current servo position, current servo position is equal to 0, which we don't really want necessarily that. We want that to be equal to the minimum. Servo current position is less than servo 1 max position. And servo current position is +1. That's all cool here. This here now is, copy this. This goes here. Copy this. This goes here. I know we still haven't got that interleaved, the interleaved movement figured out yet. I'm thinking about it. So copy this. And actually I'm going to copy, let's copy this to here. So this now is not, this is greater than, and this would be the servo minimum position. This is greater than or equal to 1. Can we just say greater than? Well, it's greater than 1. Or we're going to have to do math to say this number plus 1. Okay. Minus servo 2 max. Copy that. Copy that. Paste that. Save all that. Do compile. Yep, it compiled. All right, let's upload. See what it does, if anything. There it goes. Oop. Cool. Okay. So that works. Let me see if there's any. There's no chat. No one's asking questions. No one knows we exist. That's why no one's asking questions. All right, so cool. Let's take this then, and so let's do different values here. Let's say that this is like 40, and this is 60, and this is 15, and this is 120. So save this, and let's see what this does. Okay, it's uploading. Cool. Great. That is doing what we want it to do. All right, brain, get to working. So we know it has to be a for loop here. And likely we want to have it break after every position. So what we want to have happen is we want to have it write this, then it writes the other one. Like once this is complete, it writes the other one, and then it moves to the other piece. So this does the whole sweep. We don't necessarily want this to go the whole sweep. We want it to go for every value. And I wonder if it's like a time delta where we want those to where we want those pieces to be under something else, because essentially we want those to be interleaved. How the heck are we going to interleave those things? Maybe we don't put them in a for at all. Maybe put them in like an if statement. Now, the thing I get concerned about is that you're going through a whole big long list of things that it needs to achieve. And so let me think this. Instead of thinking about this as a for statement, can we think about it as an if statement? So if this servo, and not even worry about this because we already set that up here. So if this thing is less than this, run this stuff and then go up one. Else, or just four different if statements, or if this is less than that, else it's the opposite, and then the other needs to run. All right, we're going to move some things around, comment some things out. And I'm gonna let me label some of this stuff. What my intention is. And so my intention is here is servo 1 forward movement. Whatever forward is, servo 1 backward movement. Okay. And I'm just going to do that for now. Let's do an if. Copy. That is greater than that. Then do this stuff. This could be else. If these types of things here, down here. This is else. Will you compile? I bet you won't. Wow, if that works, I'll be floored. Done compiling. Oh, the suspense. All right, so it ran that once, boop. The question I have, the way that acted is as if it ran through all of this. It went back up because it basically found its spot it needed to be at, right? If we upload this again, it won't move at all because it will be in the positions that we have here, the initial position. And so, because what it's doing is it runs through this whole loop, it runs through all of this if stuff, and then it comes back and then goes through all this information, and yeah, so it's done uploading. It didn't move because it's, so like let's say I make this 140, and this is 160, and this is 115, and this is 180. It should move this time because it's moving to and it's moving quickly right to the position it needs to be at for its initial position. It finishes a loop, it goes back, it finds its position, it goes back, and it runs through all of this again, and then basically it doesn't have to move as it goes through again. Because again, this is looping through 1, 2, 3, 4, etc. And so now it doesn't even have to, it doesn't have to move. So that's why we had this 4 going back, so this 4 going back and forth. And so I'm going to see if my friend is available to talk. He might not be available. All right. Let's see if I can find something here. All right, well, it's going to take me a little bit to source the root of this problem out. So this will have to be continued. And once I've got a solution, I'll update. I'll do another update on this. So cool. Anyway, we're making some progress. We're getting things moving. And there's 2 things moving, but how to get those things to run together at the same time, interleaved, that's the question. So I'm looking into it. I'll figure it out, and in the next video we'll find out what that solution is. So cool. Anyway, thank you for watching. This is the very first episode of Robot Chores. I've been doing cartoon chores for a while now, and this is also going. It's also on the Grasshorse channel. So if you like the content, be sure to share, like, and subscribe, and I appreciate it. Cool. Bye.